everyone, and welcome to day 2 of the MicroStation User Conference. So if you're unfamiliar with the On24 platform, all the widgets are resizable, so feel free to move them around today. Automated closed captioning is also available for this session. To turn on captions, click the CC icon on the media player window. We encourage you to submit questions through the Q&A widget. We will try to answer these during the session, but if we run out of time, it'll be answered later via email. We recommend closing any programs or browser sessions running in the background that could cause issues. If you are experiencing problems, pressing F5 on your keyboard will refresh the page. An on-demand version of the meeting will be available and can be accessed using the same audience link that was sent to you earlier. The session is also eligible for 1 continuing education credit. With that, I'm happy to turn it over to our presenters.
Thanks, Eduardo. My name is Ken Allen, designer at National Grid. And we are part of the Intelligent Substation Design Group as a company entity given to the standardization and improvement of engineering and design. And we have 3 individuals on the call today, myself included, a designer with Intelligent Substation Design, as well as Tom DiOrio and Carlos Bowden. And we'll each be covering our respective topics in this session with you today. We've included our contact information here for you. There'll also be another slide at the end in case you'd like to reach out to us. We're very interested in networking and collaborating on these workflows that you're about to see. So who is National Grid? If you're not familiar, we are an owner-operator utility in the northeastern United States. And we operate approximately 1,200 substations in the New York area, and then another 1,200 in the New England area, Massachusetts, principally. And we have 14,000 kilometers of transmission line, as well as distribution line and sub-transmission, 7 million customers in the U.S. core business. And this group specifically is tasked with the maintenance of these substation assets. There are complex brownfield projects that we do, as well as greenfield projects to meet the demand, the ever-increasing demand of our customers. So this Intelligent Substation Design Group that we're a part of has been tasked with improving our design process and leveraging Bentley tools to do so. So prior to the 90s, it was very commonplace in our offices to have board drafters, a whole army of them, and obviously everything was done in a manual fashion. And moving forward into the 90s, we adopted some degree of CAD. The early days of Intergraph in 1982, National Grid was a part of it. And then progressing forward from there, we are now using MicroStation Connect Edition from 2012 onward. And we are embracing some of the Bentley workflow surrounding 3D design to help bring efficiencies to our design process. And it's been a long road. We're certainly not done, but we'd like to share with you some of the successes. What we found is we need to bring design up to the 21st century in our engineering offices, vis-a-vis having a single source of truth, being a 3D model rather than 30, 40 different unique 2D drawings that describe the same asset in a substation. Why not put all of that information into a single model and then export content as necessary to generate a bill of material, to generate elevations, details, sections, to check clearances even, electrically speaking. And all this will help us to increase the speed of our workflows, and it also increases the accuracy of our output, which today still remains 2D design drawings going to our stakeholders in construction for the building of these assets and then their ongoing maintenance. It behooves us to design and to engineer as efficiently as possible. So we found these tools, principally Bentley MicroStation, to help combat inexperience and augment our existing experience. If we can help visualize and help a project team visualize and conceive of these designs in advance of generating the drawings, hundreds of drawings that go into this asset, we have a leg up on the design process. Folks understand how to model and then how to describe one of our designs accurately. very early on in the design process. And we've done some studies. This amounts to approximately 60% less design time on 18% of our deliverables. So taken as a whole, that would be 11% design time reduction on one of our capital projects. And that, of course, allows us to attain our critical milestones all the more. So we're continuing to build on these technologies using what we've learned since implementing MicroStation Connect and the 3D workflows that are built in. And we'd like to share with you some of those successes today. So we began with simply converting our outlines, vendor-provided outlines for our equipment, into MicroStation cell libraries, each of them having descriptions that describe the particular component so that any designer involved in the capital design on this project can choose from a central library, insert that into a model, and done enough times have a comprehensive picture of the design, and then output that to a 2D drawing. Before, that was done all manually, and certain projects still it's done manually. We're trying to bridge the gap there and adopt these 3D practices anywhere where a physical drawing is being used in a substation. And this all fits into our greater vision of BIM, adopting BIM, Building Information Modeling at National Grid. So today we are somewhere between 2D and 3D in the phases of BIM, adopting some degree of physical automation, leveraging MicroStation Connect. So if I start up MicroStation Connect and we'll just show one of our designs, I can illustrate these cell libraries in use. We generate most green fields in this manner today, and that also helps us with standardization. When we have assets that are largely the same but just different in their geography, of course, we have the ability to carry over designs and design components from one project to another without simply copying and pasting from previous projects. Everyone can have the same set of cell libraries with which to build their design. So we built into MicroStation Connect all of our standard cell libraries, and we can simply insert any cell into one of our projects quite easily. Anyone has this ability in the company. And there, I just placed a transformer. We also have all of these other libraries divided by the type of component that they are, and place enough of them in a design file, and you can see we have a comprehensive greenfield substation. And we can automate the checking of clearances here through the measure distance commands in MicroStation, and also generate a bill of material from the data contained within these cells. And then finally, generate drawing views. Through saved views, we're able to output a plan view, a front view, an elevation, or a right-hand section view, all at the click of a button. Before, to draft these would take days, if not weeks, to progress independently of each other. Now, they all talk to each other in the same common environment. So we have additional successes that we'd like to share with you in the way of reality mesh and also with permitting. And so to continue this, I'll turn things over to Tom DiOrio.
Thank you, Ken. I have my screen up here. All right, I'd like to talk to you about a station that is recently built. It's actually in the final processes from the redesign that we had to do. But this is a station that has been in production process for about 3 years, and it was done by an outside one of our outside contractors. Unfortunately, when they did the design and it was missed, they used the wrong voltage standards drawings that we had, and unfortunately, they used 13.8 kV, and this is a 34 kV yard. So you can see that it will probably have a lot of just clearance issues with switches and other assets that we have in the bays. When this came to light, it was late in the game, and they needed to get some answers, and relatively quickly. So And they would have actual design review meetings every day with the with people, the stakeholders and the subcontractor to come up with the solutions. And they would have these 2D sketches that were redlined, and they would try to present these during the meeting, and people were having a hard time visualizing where they were in the yard and how things were from one side to the other. So they asked us if there was a way that we could do a 3D of the station where this problem existed, and if it would be something that we could do in a relatively quick fashion. Luckily, we had our standard model created for the 13.8 kV yard, and we were able to take on most of those components and recreate what the contractor had done in their design. And then from that, in the meetings, we were able to zoom in, show the differences in terms of spacing much quicker. I'll just zoom in here real quick. And this didn't take very long to create, since we had most of the information in our cell libraries that Ken had just shown you a minute ago. So we were able to reproduce this, actually be in the meeting, and when someone had a question, we were able to spin the model around, get into the right view, and answer any questions that might have come up. And from that, we were able to make, if someone had a question, I could easily come in and I can create a section. And then from that section, I can come in, let me just turn that right, okay. And let's say, let me go to the top view. Just to show you how we were doing things during the meeting. We wanted to see this bay right here and how the connections were. And bring this in like this. Oops. Go. And then if I do clip volume, I get that section that I need right there. And then I can view that, we can look at it, and if someone had a question about the other side, then I can go right back to my top view. I can now change the direction. Move my cut plane to the other side. Just bring it back a little more. There you go. And now if I do the same thing and view that side, now I have the other side. And we can quickly see the two views. All right. Now, just in comparison, apologize, something screwed up there. I can't get that back. Here we go. As you can see, it's much cleaner to see the difference between the mock-up and the actual cut sheet from the model, all right? And the same goes with the next one. That's from the other side. Oh, sorry, right there. And we can easily see what's going on, and we can zoom around. And then the last thing that we did, and the beauty of it is we could do this right during the meeting. We could see the changes and make them right during the meeting if there was an objection to something. So all the stakeholders involved were satisfied with the design that we were coming up with. And then the beauty from that is once this is done, we can take those cut views and we can actually apply them to the 2D cut sheets that need to be made for the new material that needs to be ordered. And this cut the design time down by weeks in terms of getting the model together and everyone being on the same page. Everyone was ecstatic. They loved the model. They loved being able to move around and see it from the different perspectives. And as just as an added bonus, we took the model and we were able to put it into content capture, and we just created this quick little video to demonstrate how we were able to put this all together. Just from talking and getting the different inputs from the different stakeholders, we were able to put this all together in a matter of about 2 weeks. And the beauty, too, is that we were able to show all the clearances and any changes that needed to happen pretty much right on the spot. And what I wanted to show as this comes around is the biggest problem in the clearances was with the switches and the underhung switches. And as we come around, you'll see we were able to actually actuate the switches. There we go, right here, to show what it will actually be like when the switches are in their open position, and to show that the clearances would be met. And since this has happened, we're getting more and more requests from different groups to help assist them in some of these situations that they're finding themselves in. And that's pretty much what we're doing as far as the modeling and how we're affecting actual projects that are happening right now. And with that, I'll turn it over to Carlos, who will show us how we're doing some content capture and reality modeling for permitting. Carlos?
All right, thanks, Tom. So what I have here is a visual rendering of a project that was used for permitting. Views were taken from different locations in this area, so the local town people could actually get a good clear line of sight of how this new tower that's shown right here is going to affect them or look inside their neighborhood. The orthographic and LiDAR images were downloaded from the state's site. So, well, basically this was allowed to, when you get download from the website, we then took the files, imported and processed the files in MicroStation to create this rendering, the visual rendering you see here. There's a substation that's shown. Let me darken it up just a little bit. And in this view right here is a view that was taken from someone's that's close to their driveway. That's what they'll be actually seeing there. This file, this process also was taken and exported to Google Earth so they could see a final presentation of the product. Now, just when we're around here, you can actually see the substation here and how the layout of the area is. When I go into Google Earth, once the file is exported, this is the physical rendition of the files that you have there. This is the same substation, and right here, you see the antenna. Now, I'm about to start turning the views around. You can actually get to see the same layout that was in the MicroStation file that we have. And this is the presentation that was given to the people so they could see how this tower will affect the outlook of the neighborhood. So this is what shows, this is the outcome of the representation of the file that was given to our company to represent them for licensing. And with that, I give it back to you, Ken.
Thanks, Carlos. Nice demo there. I think that's some very engaging visuals. And also, Tom, with the project you showed us, making very quick changes on the fly to an existing substation design is pretty unprecedented for us. So using these new technologies has decreased the time to output immensely for us, to the point where we're confident in saying that applying these technologies along with a few that we don't have time to present today, at the 3-year mark, We are confident we can achieve 11% design time savings with the application of standard designs surrounding these technologies on approximately 35 of our projects in our 5-year capital plan. And then at the end of the 5-year mark of our present capital plan, we hope to achieve 40% design time savings on another 21 projects. And so we are actively pursuing this. We've had projects earmarked for these technologies, a selection of 3D, as you saw with Tom, or LiDAR, as you saw with Carlos, or both in some instances if it's a complex brownfield. And then we're hoping to apply our standard tools to achieve that level of standardization, the higher accuracy, and the increased speed of production. So we're well on our way. And I want to mention that these workflows are not uniquely ours. We have been partnering right along with our various contractors, pictured on the right-hand side. And we are interested in furthering these workflows. We've also been in communication with our sister owner-operators, Duke Energy, Pacific Gas and Electric, American Electric Power, Hydro-Quebec, and PPL, endeavoring to apply our own degree of industry benchmarking to these workflows and ensure that we are pursuing best practice. So I can't stress that enough. We are interested in continuing to develop and refine these workflows. And if you think you have some good suggestions for us, we're all ears. And we look forward to working with our contractors on these projects going forward. And with that, with the time that we have left over, I'd like to turn things over for questions. There's a lot that we couldn't cover today. As pictured here, we've generated reality meshes using context capture. We're able to share those meshes with project teams for dimensional inquiries and save on site visits, time in the field. And then also in some cases generate dimensional outlines to collaborate with our vendors where drawings wouldn't have otherwise existed and measurements weren't possible on an energized asset. So there's a whole suite of technologies here that we're pursuing under the umbrella of intelligent substation design at National Grid. And Carlos and Tom and I are helping spearhead that effort, and we're happy to take any of your questions.
One question is around the relationship with some of your stakeholders, and thank you very much for sharing a little bit about some of the companies that are working with you. But can you tell us a little bit more about how do you collaborate with them? Do you share your CAD standards with them? What is the access, or do you use any project management tool to make sure that they have access to the right data at the right time for the right project?
Mm-hmm. Yeah, so we are in the middle of transition with that. We have a content management system today that we are actually in the process of migrating over to ProjectWise. And so the hope there is that once ProjectWise is fully set up, we will have our MicroStation workspace with all the tools that we demonstrated here available to any and all of our contractors. And then also the ability to share our drawings directly and have a user at one of those entities check out files, make modifications, check them back in, and submit them for review all within our system. So in addition to that, Eduardo, we do have a set of standards, a 2D CAD standard, one for New York and one for New England, and then we also have a 3D CAD standard describing some of these new workflows shown here today that is shared between New York and New England.
Maybe one other question around deliverables and the way you are positioning National Grid for future projects. And it's great to see that you are migrating from drawing-based workflows into a 3D models-based workflow. But maybe another question around the digital transformation process that we are going through right now in our industry. do you see those models and some of them that you showed us today being the future baseline for digital twins, or taking those models into the management of those assets after you deliver those projects in the future?
Absolutely.
And if great, and then if you do, can you tell me a little bit more about how do you see that delivering better value for your final customers in terms of time saving, or more environmental friendly infrastructure, or any other types of value that brings to the project?
Yep, sure. Yeah, so these are very early days for us still with these technologies, but to answer your question, we see great potential in starting each project, each of our substation capital projects, with a centralized 3D model to describe all the physical components and geometries of the design. And then we are actually looking to progress further to capture some of that efficiency gain in our electrical schematics as well, although that effort lies ahead of us still. But taken as a whole, to be given the ability to model an entire project up front with all of its constraints accounted for with standard parts, we see as being a huge boon to the design process, where today it's not atypical to spend months, if not years, on one of these projects. And then in the process, of course, there are changes to the material that we source from our vendors. There are changes to our standards that require us to modify geometries. So if we can speed up the development process, as well as visualize it all up front and get the team on the same page, we're looking at efficiencies that stretch far beyond just the design process. We're talking about the ongoing operations and maintenance of the asset, the ability for someone in our field personnel to hold an iPad and have a 3D model up as a training tool for their technicians, to be able to direct them as to switching operations, take measurements on the fly, again, of an energized asset that they couldn't otherwise gain access to. All of these benefits are present through the life of the asset, in addition to the accelerated development of design output, which today still remains our 2D drawings. But we actually have quite a few plans lined up. We have a leadership team who is asking, how quickly can we do this? Can we apply these technologies to our whole service territory so that we can get this factored into the life cycle of these assets as quickly as possible. So we are embarking on that effort. The company as a whole sees the benefit to it. But again, it's early days. We do have a lot of work ahead of us. Yet we see the benefit, to answer your question.
Maybe one last question, still looking into the future, and of course you guys are one of the large owner-operators in the country, and you employ a lot of engineers, designers, architects every year. But what advice would you give to the students that are now starting or are in the middle of their engineering course, or are learning at the moment design, and how do you see the future of the industry? What would you tell them as they come and start entering our industry?
Mm-hmm. Tom, you want to take that one?
Yeah, I could talk about that one. Just like when I first came into the industry, CAD was just starting to come out. I was into graph back then, and they gave us the opportunity as engineers if we wanted to learn CAD. And I jumped at the opportunity, and it's been beneficial ever since it's grown dramatically since then, just from doing straight little 2D drawings and then getting involved into the 3D world, and that growing at such an exponential rate. It's just a great thing. And so what I would say to the students coming into it is keep your eyes wide open, take on the new intelligence that comes with open arms, or be eager to learn it, because it's so beneficial, and it's something that's just going to keep growing. So you might as well grow with it.
Yeah, I think, just a word on as speaking to other owner-operators out there who, we have capital plans to deliver. We have existing assets that are aging. There might be some reticence out there about adopting these workflows, these technologies, while keeping operations going. And, we, as National Grid, fellow owner-operator, we want to say that it is possible, it is worth it, and it can be done. Today we are a mix across the board. We pursue some projects still in the manual fashion, but this is our end game, and we do see the benefit, and we've got a management team, thankfully, that sees the benefit. So we would encourage everyone out there to pursue these same workflows if maybe you haven't already.
Great. I just want to thank our guests from National Grid for their awesome presentation, and thank you to Eduardo for sort of moderating the session today with them. We are receiving your questions, and we do plan to direct your questions to the National Grid team, and they'll be able to follow up with you directly since we are a little bit over on time. So we want to thank you again for joining us this morning, afternoon, or evening, wherever you are. And we hope to see you on one of the other sessions today and tomorrow. So thank you so much. And